Can you able to see the screen?
Yes, sir.
Okay. So we have ended with the topic in this model 3. That is what is the last topic what we have discussed as find the cosets. Okay, they will be provided one set as a group. At the same time, they can give the one subgroup. Okay, so they will be asked you to determine find all the cosets of this H with respect to G. Okay, they can ask the question like this. There it was classified like right coset and the left coset. Can you able to get my voice clearly?
Yes, sir.
Okay,
Yes,
fine.
sir.
Yes. So we have determined the left coset or right coset depends on the question what they are asked in the problem. Okay. So there we have applied the method is called A star H or H star A. Okay, that was the topic we have ended with the last class. So before enter into the current topic, so now I just would like to point out only one thing about your in your question. Okay, because I have noticed in your cat one review around many of the guys have done the mistake. Those who attended this question. First, I'll show that question to you. See here. Mostly you have done the mistake on this problem. First, let me explain about this. Actually, in this, there is no doubt to derive the closure and then associative. Everyone has written correctly on that. You have started to do the mistake only on the part identity and then inverse. Okay, so anyway, in this case, some of the guys have written very clearly and correctly, so that's a clear that we should appreciate them anyway. But I'm just pointing out for the on the base of the major mistakes have done by the many of the your class members. That's why I just need to spend 2 minutes for to explain that. Sorry, identity and then inverse, and then we can move on to the next current topic. Okay, see here in this problem, it was given the order like x x x x. So that means what it tries to say, all the four elements should be same. For example, if suppose if there is a element x as 4 means all the four elements of this matrix as a 4 4 4 4. I hope we can understand. If suppose if it is 5 means 5 5 5 5. There should not be varied with 5 0 0 5. Okay, many of the guys have written wrongly like your identity element is here like 1001. Okay, that is not a way what they are given as the problem. Here their assigned task is to be then certainly that 1001 will not be the member of G, right? So this contradicts to our law. So here you could not determine the answer. So in this case, how it can be determined the identity element, that we should know. See here, for example, we can just consider the same problem. So in this usually what it tries to say, AE equal to EA equal to A, that is the identity element. So here where AE belongs to the matrix of G, that it represents x x x. Okay, so x x x. So here I can consider matrix A as x x x x. E represents as E E E E. So I should get A, right? So A as x x x x. So if I apply multiplication A with E matrix, I should get the same A matrix. That is the rule what they are assigned as the identity property. So here let me determine the multiplication between these two matrices. So I will be getting the answer like xe plus xe, because xe plus xe, so that is 2xe. So likewise 2xe 2xe 2xe. Okay, so still in the right hand side I can keep the same value x x x. So I'm allowed to both the matrix are equal means I am allowed to equate with the with respect to the each element. So here certainly I can show 2xe equal to x. Okay, then E equal to xx gets cancelled, 1 by 2 will be the answer. Many of the guys have done the mistake like E equal to 1 by 2. Identity element exists. That's it. No. I have cut the marks for that 2 or 3 marks for that for this reason only. You can even notice that. See here, it is not a matrix. You have determined just element of one matrix. Okay, so that means the element in which matrix you have determined just one element. So after that, you need to arrange properly as the identity matrix as 1 by 2, 1 by 2, 1 by 2, 1 by 2, which belongs to which belongs to G, which belongs to G. There, what they are mentioned, in which all the x can be the set of real numbers as the set of positive real numbers. They didn't simply say like whatever the answer you have determined as e equal to 1 by 2, as simply you should put as the identity element. That is an invalid answer. Okay, so you need to mention like this. That points you should to note down, because it should not be repeated when the fat exams comes. Okay, this is the internal, so but it should not be repeated in your fat. That's why I'm just spending time to repeat your mistakes. Okay, likewise you can proceed to determine the inverse element. After this you need to mention like identity axiom is true. Next step is a a inverse equal to a inverse a equal to, you should get the answer as e. So here again I can consider a as x x x x. A inverse can be considered like a inverse a inverse a inverse a inverse. E already you have determined the answer, that is 1 by 2 1 by 2 1 by 2. Let me complete quickly. Okay, after this you can take a multiplication. Surely you will get the answer in the form like 2x a inverse 2x a inverse 2x a inverse. So the answer here it will come like 1 by 2 1 by 2 1 by 2 1 by 2. So let me compare with respect to each element. 2x a inverse equal to 1 by 2. After that a inverse equal to here 1 by 4x. Many of the guys have written like 1 by 4 alone. That is not a correct answer. So after that you need to mention your inverse matrix as 1 by 4x 1 by 4x 1 by 4x 1 by 4x. That will belongs to G. See, all the four elements are same. So it is trying to justify the element sorry matrix. It is in the shape of G. Okay, so after that you can close the answer. Since inverse axiom is also true, I can complete it's a group, it forms a group. Okay, have you understood on these two axioms? Clear? Have you got it?
Yes, sir.
Yes, sir.
Okay. Yeah, I didn't worry to spend time for this, because I have counted around, I think 17 or 19 members have done the mistake on this, so that's why I have just planned to spend for this. But anyway, because of the slot wise, it may not come for the certain students, because it may be shuffled in randomly. It can be assigned for some of the guys. Many of the guys didn't notice this questions was asked in this exam. Okay, but anyway, it's a good practice for everyone, so please keep in your mind. Please don't do this mistake in your fat exam. Also they have mentioned, some of the guys, like simply they are mentioned in your inverse determination. You have determined like a inverse equal to 1 by determinant of a into adjoint of a. No. Okay, I have pointed this. When the numeric entries have come, means that time only it will be possible to determine the answer like this. In general, you should not determine like this. Okay, you can just even check. You could not determine the answer. Okay, so this case will be applicable only when you have determinant of a not equal to 0. But in this case, you can just check what is the determinant of a of this problem.
0.
0. But many of the guys have written like inverse axiom. In the point you have mentioned like a inverse equal to 1 by determinant of a into adjoint of a. So you should not mention directly like this. Okay, it won't apply on this problem, so please understand. If they are asked you to determine the inverse element, means you need to apply the inverse rule, and then you need to get the answer like this. Okay. Okay, now we can step into the our current thing. See here, this is Lagrange. Okay, so here already I've told you. So since we are at virtual mode, so there will not be asked any direct theorems. Okay, state and prove Lagrange's theorem. At the same time, instead of this, they can give the statement and then they can ask you to write the proof for that. Okay. Previously, it was conducted in the physical mode, so that time these are the questions were being very important concepts. They never skip this kind of important questions in the physical mode of semester exams. But in this case, what we have instead what we are instructed not to take this kind of open theorems, okay, because it should not be asked. That's the instruction was provided. So I'm not going to enter into the clear proof for that, but I can just simply want to explain about the statement, and then I can skip about the theorems. If it is needed, you want to explore more knowledge about this theorem, you can just refer the Google, or you can ask me personally. I'm ready to share the complete proof for that. Okay, so here Lagrange's theorem statement says like order of each subgroup order of each subgroup of a finite group is a divisor of the order of the group. See here, order of each subgroup, what they are trying to say, order of the subgroup. So first let me explain, let me introduce let G be a group. Okay, you can define like let G be a group, let H be a subgroup of G, subgroup of G. After this, what they're asked you to show to prove that order of the subgroup is the divisor of the order of group. So that means order of G divides order of H. Okay, already you have come across the definition of order. What is the definition of order?
Number of elements in the
Very
subgroup.
good. Number of elements in the group. Okay, that is called order of the group. So there you need to count the number of elements in the H. That is the value of order. Okay. So here sometimes they can define like order of G as M means you need to show the answer like M by N. Okay, that can be m and n are finite numbers, then only you can able to count, right? So there will be some procedure to determine the answer. The procedure will is applied on this theorem to derive this part. They are applied the coset's concept, left coset or right coset. They have applied that and then they have determined the answer. If it is needed, I'm ready to share the proof. Personally, you can chat me, I'm ready to share the proof. Otherwise, no problem, you can, because it's not important. They never ask in the exam point of view, because since it's a virtual mode, they could not ask these questions. Okay, you can leave that. Okay, now, okay, now we can enter into the last subsection of this model, that is very important subsection, that is group code. Okay, group code. So here first you need to know what is group code. Okay, what we are going to solve in this subsection. See here in this section, they will be provided some codes. You have already known with the other technical terms like encryptors or encryptions. You may have some codes like this: 1 0 2 0 1, something like. Sorry. Okay, so you will be provided the codes like this in this format. After that, uh, you are supposed to transmit this code to somewhere to the reception. Maybe you are going to transmit this code to somewhere at the end. Okay, one person will receive this code. Sometimes they can get the chance to receive the same code without any noise into that. Noise means there will be some trouble in the intermediate situations. Okay, sometimes without any interruptions, without any noise. He can get the original code what he has sent. Sometimes he can get some errors with some digits like 11010. That time your task is assigned here to determine at which positions it is getting error. You need to rectify those errors, and then you need to write the correct code of that. Okay, that is a process you are going to solve as a matrix oriented problem in this section. This is called group codes concept. You will be provided on code. That code may be transmitted to somewhere. Sometimes if it is reached as a originally corrected code means there is not a problem. If it is reached with the errors means your task is assigned here to rectify those errors. Okay, that is a problem you are going to solve in this group code concept. Okay, so here uh, first, let us understand what is the definition of group code. That is already we have discussed. So group code is nothing but it involves with the numbers 0 and then 1. You need to understand that first. It involves with the number 0 and then 1. At the same time, it can have the numbers as a finite digits like 1001111, something like whatever may be the digits. All the digits should have either 0 or 1. That should be a finite. That's what they are discussed. uh, at the same time, is a group. It's a group. Okay, it's a group under binary operation of addition modulo 2. Here what they are saying, it's a group. Here you need to apply the operation, only one operation, that is called addition modulo 2. For example, you can consider this code 1011, or one more code as 1111. Sometimes they will be asked you to add those two codes. If the question is asked like this, or write the summation of these two codes means, you need to apply here normal. You should not apply here normal addition. You need to apply the addition modulo 2. 1 plus 1 2, 2 mod 2, that is 0. So 1 plus 1 2, 2 mod 2 0, 0 plus 1 1, 1 mod 2 1. So that is, so this will be the answer. Sometimes 100 111 or 0101. So in that case, okay, so 1 plus 1 plus 1, what is the answer with respect to addition modulo 2? Can anyone?
1.
1, because 3 mod 2 is 1. So that's why I have just given the example by adding 3 codes. Okay, so likewise this is 0, this is also 0, this is 0. So this is the answer for this. So why I have pointed this example means that you need to come to know, you need to fix in your mind, you are allowed to apply only one operation, that is addition modulo 2 operation. Okay, last definition, with that I'll close it. Okay, see here, next definition is called Hamming distance. Hamming distance is nothing but you may have some like you may have two set of digits. Okay, two set of codes like 1011. One more thing like 1111. Okay, in which if they ask you to determine the Hamming distance between them means, you need to simply take a look on at how many number of positions it is varied. By comparing these two codes, at how many number of positions it is varied. So here how many positions it is varied?
1.
1. So Hamming distance between them is 1. That is the answer. See, for example, 1 1, it is same. I can put like 0. Next 0 1, it is varied 1. Next 1 1, same, no change. Next last one is 0 0. So answer for this 1. So likewise I can just extend the number of digits like, okay, what is the answer for this Hamming distance between these two codes?
1.
1.
1. Very good. Okay, 1 is the answer. So you need to you know, you should not fix your mind always. It can get the answer as 1. So it is randomly I have given the number. What is the answer for this?
3. 3.
So
One digit is missing.
So,
yes.
Hammond distance can be found for X, Y, Z numbers as well, right? Three different numbers, or no?
Sorry, I cannot get your questions. Can you please repeat?
Hammond distance can be found between only two numbers X and Y, or it can be found between three numbers
Very good,
X, Y,
very good,
Z.
very good, very good. Good question, good question. See here, sometimes they can ask between three numbers also, x, comma, y, comma, z. That time you need to apply the process like x into having distance between x and y, having distance by between x and z, and then having distance between y and z. That means with respect to every pair, there which what is the least one, that will be the correct answer. Can you get it?
Okay, sir. Thank you.
Okay. That example also will be provided in the next class. Okay. Now we have started with the very basic definitions of group code, and then last one is Hamming distance. Any doubts up to this? Is it clear?
So in that
Yes.
addition thing, so that's basically a binary addition, but just without carry. That's it, right?
Yes. There is no normal addition. There will be the binary addition. That's it.